Hello, my name is Corina Ciocan. I'm a principal lecturer in marine ecotoxicology at the University of Brighton in the UK. And today's presentation is on the impact of boating industry on coastal ecosystems. This presentation refers to the impact of fiberglass boats, the small to medium boats that are built using fiberglass reinforced plastic material. This material has been created in the late 1930 and it was considered a wonder material because it was very light, waterproof, very easy to manufacture, and it was very quickly adopted by the boating industry. Nowadays, the material is found in wind turbine blades, in pipes, in roofs, even in small furniture. With a life expectancy of more than 50 years, this material is definitely the preferred one for the boating industry, and therefore many old boats are still in practice. However, there is a number of vessels that are not in use anymore, and what we call the end-of-life boats, and most of them rest abandoned in various corners of the world. The boating industry is booming nowadays. After the pandemic, after the lockdowns in 2020 and 2021, more and more people want to be on the water. So those are the prediction for the growing of the boating industry. As you can see, from 2020 to 2027, we are looking at more than quadrupling the number of boats that are going to be manufactured and released, for commercial use or for personal use. This growing tourism is probably fueled by, as I said, the desire of the people to be out and about, but also by the extra income that is available due to the ceasing of all activities, during lockdown. Well, what are the consequences? Unfortunately, this material is not recyclable, and most of the boats, the end-of-life boats, are taken to landfill. Some countries, they do have a lot of space, and taking such a huge item to landfill is not necessarily a problem. But we are thinking of small islands. UK is an island, and the space in landfill is very, very limited. But there are a lot of other islands, like the Caribbean islands, that are facing exactly the same problem. So here you have some beautiful pictures that have been kindly provided by a journalist, an English journalist, Ray Hobbs. As you can see, those are GRP boats or FRP boats, so glass reinforced plastic or fiberglass reinforced plastic boats that have been abandoned in various areas in the UK. Sometimes right on the edge of the water, sometimes a little bit more hidden, in areas that are densely vegetated, and they are somehow hidden. Some of the boats, like in this picture, some of the boats have sunken, and they are actually a hazard, a navigational hazard, but they are also a hazard for the inhabitants inhabitants of that area. Sometimes there are reports of children playing, considering that those boats are a playground, and they are definitely very, very dangerous because they are unstable, because they have sharp edges, because they are actually full of various chemicals that are toxic to human health, to humans. In the left corner, you have a diagram of a boat, of a sunken boat, and you have some specific numbers over there that will point out the various types of chemicals, various type of contaminants that are leaking into the water, or that can come in contact even with the terrestrial environment or with humans when they approach those abandoned boats. And on the left corner down, you have a picture of a destruction caused by a hurricane in the Caribbean. So the end-of-life boats constitute a problem for most of the countries because, as I said, because of the lack of the recycling. But also new boats that are still active, they can be damaged to the point of no repair by environmental forces, environmental events, and therefore the authorities facing a massive task to clean up those marinas and to take those boats somewhere, not necessarily landfill. As I said, sometimes this happens in small islands in the Caribbean, and landfill is very, very limited. So the options are very, very restricted. In Europe, for example, a recent survey commissioned by the International Maritime Organization in 2020 estimated that there are 6 million boats. Fiberglass boats, 95% of them are fiberglass boats. Every year, about 1 to 2% of those boats, so up to 120,000 of those boats, reach the end of their life. Of this, only 2,000 are recycled, and about 6,000 to 9,000 are abandoned and accounted for. So they are visible. The authorities can point them and can make, necessary preparations so that they can retrieve those boats and take them to landfill. So a total of up to 110,000 boats every single year disappear. Old boats that are abandoned somewhere where it's very difficult to be accessed, a place that is quite hidden, or simply taken offshore and sunk. The principle of out of sight, out of mind. Why is this happening? Why we have this inappropriate treatment of end-of-life boats in the EU? Well, this is basically because we have no legislation, no uniform legislation that will help the owners to dispose of their old boats in an environmentally friendly way. And this is actually fueled by the fact that there is no recycling for this material. There is no harmonized legislation at national level or at international level to actually find a solution, to find an environmentally friendly solution to recycle those boats. So how do you get rid of an old boat? Well, you put it on eBay. You sell it for anything from €1 to €100 if you want, and then it becomes somebody else's problem. So to deal with those end-of-life boats in an environmentally friendly way, it is estimated that we need about €80 million per year only for Europe. France appears to take the lead by creating APER, a national organization collecting an eco-tax for the new boats registered only from 2019 and the French pavilion. The tax is expected to allow for about 6,000 end-of-life boats per year to be recycled, dismantled. It's a huge number compared to only 600 that are undergoing this process at the moment. So this tax range from 17 euros for a sailing dinghy under 4 meters to less than 400 euros for a 10 meter boat, and about 10,000 euros for, you know, a big yacht. In terms of pollution of the or impact of boating industry on the marine environment, it was only recently that the shipping industry has been acknowledged as a source of microplastic pollution. It is a well-known fact that marine paints comprise several plastic types: epoxy, polyurethane, vinyl, lacquer. A paper published in 2015 identified polyacrylate microfragments from GRP of FRP and from coating, mainly associated with small boat hull and their breakup at the end of life on the coast of South Korea. Also, another study in Germany, based on the estimate that more than 50% of the marine paint is actually plastic. This study calculated that around 500 grams of dust material containing plastics and related anti-fouling, you know, or heavy metals as well, is created per square meter of ship hull every time that ship is cleaned. So for a 10-meter vessel, for example, we have 5 kilograms of dust that is created and released into the environment. It is also reported that about 6% of the solid plastic coating is actually lost directly to the sea during the lifetime of that coating, so during normal operation of the vessel. And therefore, the study calculated that about 330 tons per year are lost at sea only from Norwegian boats. A huge amount of plastic. So boating industry is contributing with this huge amount of plastic to the contamination, to the pollution of the marine environment. And therefore, a very recent study in Germany in 2021 actually confirmed that most of the microplastic that is present in the marine environment is actually coming from the boating industry. But it's not only plastic. We have a lot of other contaminants that are present in the marine environment that are polluting the marine environment, and they are associated with the boating industry. Those are ions like copper or chromium or lead. It's TBT as well. There are chemicals that are contained in the anti-fouling. There are also fiberglass. There is that little component, that very fine component that is present in GRP or FRP, and those are the fiberglass. And those fiberglass are released into the atmosphere or into the water when the GRP or FRP is degrading and it's exposing the fiberglass, like you can see in the picture on the right corner. And those fiberglass, they have been considered to be carcinogenic and also they are considered to be asbestos-like fibers. Exposure to fiberglass contributes to the development of pathologic alteration in the respiratory system in humans, causing deep irritation of the lungs and sometimes progressing to cancer. So a whole array of materials, but also chemicals, also microplastic particles, are actually polluting the marine environment, and probably a lot more on the coastal areas rather than in the open ocean, coming in association, in direct association with the boating industry. What we can do about it? Well, at Brighton University, we are trying to mobilize the coastal community to gather more evidence related to this coastal contamination. We are running a series of community-based research projects where we empower the community to collect water samples, to collect sediment samples, to record and report the instances of abandoned boats, the very clear instances where the abandoned boats are actually having an impact on the coastal environment, like photographing, taking, recording and photographing the areas around the abandoned boats where pieces and fragments of the boat or paint or leaks from the boat are visible. So all this evidence is absolutely necessary so that we can put pressure on the authorities so that a solution can be found as soon as possible. We have a very good relationship with various communities, not only in the UK, but also, across the globe, in Canada, for example, in the United States. We have a collaborator here in Ibiza as well, in Netherlands, in Romania. So those are people that are involved in various activities related to the water. Some of them are boat owners, most of them are boat owners actually, and they recognize that there is this lack of interest from the authorities to find a solution for the end-of-life boats. And we have a very interesting example of a very old gentleman in the UK who, at 85 years old, he wrote me a letter last summer to say that he's very passionate about this project, because he really wants to put a lot of pressure on the government to find a solution for the end-of-life boats. He admits that 50 years ago he bought a boat, he called her Justine. He was very, very careful with the boat, and he was very happy to have that boat, and he and Justine had many wonderful moments, wonderful holidays for about 20 years until 30 years until he thought that Justine is a little bit old now, so he wanted a newer, a shinier boat. So he sold Justine, he bought a new one, and so on. Many years, 50 years later, he was walking on the beach next to his house, and he saw Justine broken, abandoned, almost completely destroyed, a very, very tragic sight. And then he realized that actually the boat owners, they do have a duty to take care of the boats until the end of life. So if there is a little bit of insurance policy that they can pay into, so that at the end of life the boat can be dismantled and can be maybe bits of the boat can be recycled, but all the other the material can be dismantled in a very environmentally friendly way, that will be a big step forward compared to the massive abandonment that we are facing nowadays. Now, I've done my expertise is ecotoxicology, so I am interested in the impact of stressors from the marine environment, from the aquatic environment on marine organisms. So my research actually has a very clear focus. I am looking at those contaminants that are leaking from the end-of-life boats into the marine environment, and how those contaminants are actually affecting the aquatic organism. And this is my latest focus now, is the GRP or FRP, the glass reinforced plastic. As you can see, the material is made up of fiberglass sandwiched in between two resins or two plastics, and when the material is cut or scraped, you end up with this powder, white powder, that under the microscope, the image on the right corner, under the microscope it looks like fiberglass, a combination of fiberglass and plastic. So we run our summer of sampling in Chichester Harbour in the south of England, where we were interested mainly in collecting microplastic, and we wanted to see what is the actual contamination with microplastic in the area. So we collected water, from the top surface of the harbour, and we also collected sediment, but we also collected oysters and mussels. And it was no surprise that we found a huge quantity of microplastic in all of the stations, all of the areas that we actually sampled, with water, top layer of the water probably being the most contaminated. And this is one of the most important finding that we actually reported at the end of our sampling campaign, that the top layer of water, the 5 millimeters of the water column, is the one that is most affected by microplastic contamination. We have about 10,000 particles of microplastic that are accumulated in the top layer of the water, with the subsequent 10 centimeters of the water column only holding about 2,000 microplastics per liter, and the 50 centimeters in the water column only holding about 200. So this is very important, because when it comes to comparing microplastic contamination in different areas around the world, you hear or you read, that, I don't know, in the Caribbean we have 2,000 particles per liter, in North Sea we have 5,000 particles per liter, or so on. The important thing is, how was that water collected? Was it collected from the top 5 millimeters layer? Was it collected from, the water column deep down, 1 meter below the surface, and so on? So obviously the distribution of plastic is very unequal, because of the floating, of the density of the particles, of the chemical composition, and then also of all the fouling, all the epiphytes, all the organisms that in time they're going to accumulate on the plastic particle, and they're going to make them a little bit heavier. So this was our first conclusion in the Chichester Harbour. Then we looked at the microplastic in shellfish, and we could see that there is a size distribution that is different in oysters compared to mussels, which is now very well established. So oysters, for example, they do prefer some very, very tiny particles. So they ingest a tinier, smaller particles than mussels, for example. Whilst in oysters, most of the particles were up to 100 microns, in mussels, they were between 100 and 500 microns. Then the color is completely different as well. But this is not necessarily because they can visually select the particles. It's more related to the fact that oysters have access to plastic that is closer to the sediment or deposited on the sediment, whilst the oysters were hanging on the poles or on the ropes, and so they had access to the plastic that was present in the water column. But what was actually very interesting is the fact that we found those fiberglass, those glass shards in oysters and in mussels that were collected in Chichester Harbour in the south of England. And we found a lot of them. As you can see, they look exactly like small transparent tubes, like small shards. They have been identified by Raman and micro Raman, and we know for sure that they are glass E fibers, and we identified up to 7,000 pieces of those fibers per kilogram oyster. So a huge amount of fiberglass in oysters, a little bit less in mussels, about 2,000 particles per kilogram. This was a discovery, something that was completely astonishing. The only evidence, the only previous reference that we found related to the fiberglass was this paper that was published in 2009 in Marine Pollution Bulletin, where two fibers of fiberglass were actually identified in the stomach of mussels. And so our next step was to publish our paper in Marine Pollution Bulletin, where we actually discussed that fiberglass is present in the marine environment. We presented evidence that fiberglass can be identified by Raman and micro Raman, and we consider this fiberglass as being a new emerging contaminant, something that hasn't been reported before, but something that is definitely present in the environment. And it's not only fiberglass. As I said, the glass reinforced plastic and the fiberglass reinforced plastic has two components, the fiberglass in the middle and the two sandwiched between two resins. And those resins, those plastics are some major polydiallyl phthalate groups. And those groups, phthalates, have been identified as being some massive endocrine disruptors, chemical components that have an impact of behavioral mechanism in humans and in other animals. They actually impair communication, they impair brain functioning, and they also have an impact on reproduction. And so the plastic that is shed by the GRP or FRP is contained in this category of phthalates, and those are microplastics that are actually polluting our coastal waters, and they can have an impact on the marine organism. And we all demonstrated that in mussels, for example, we identified histopathological conditions after exposure to GRP powder. We identified plastic and fiberglass in the stomach of mussels. We also identified inflammations in the gills, hemocytes invading the gill filaments, inflammation of the gonad as well. So only 7 days, a 7 days exposure to tiny concentration of GRP led to massive inflammations in various organs in mussels. We also run an experiment on Daphnia, on water fleas, and that was even more distressing because we demonstrated that fragments of glass fiber and fragments of microplastic actually attach to the exoskeleton of Daphnia, and slowly the animal is unable to swim, is unable to free himself from those microparticles and from this fiberglass, and the body of the animal becomes very heavy, and finally the animal is going to sink and is going to drown, is going to die. So some very disturbing effects of GRP on 2 different categories of organisms in the marine environment, and this is only after a very short exposure. In water fragments, we also identified that those fiberglass are able to spear basically the organism and detritus that are present in the coastal environment, and so even more disturbing to hitchhike a ride from the area of contamination to another area, or to enter the food chain. Here in the middle picture, you have a small snail, a small marine snail that is pierced by a couple of fiberglass. That marine snail, it's, as you can see, 500 microns, so half a millimeter. It's not even visible, and that is going to become food, is going to be predate by another organism, and therefore the fiberglass is going to enter the trophic chain. A second paper that we actually published about a year ago refers to the natural degradation of this fiberglass. So the natural shedding of plastic, of painting, of anti-fouling, and in the end of resin and fiberglass in the marine environment. So major points of contamination of the coastal environment are obviously the boat yards, where a lot of work happens. You know, the boats are cleaned, are cut, are repaired. So this dust, this fiberglass and plastic dust is very common. But at the same time, those components of the fiberglass are leaking into the environment in a very natural way, only by the weathering of this material. So this is a picture of an end-of-life boat waiting to be taken to the landfill somewhere in South England, in Chichester Harbour. And as you can see, the boat looks very old. It has cracks and holes, and through those cracks you can see the fiberglass. So this is the exact image of the toxic components that are able to leak from the boat into the environment, into the sediment, and then have a potential impact on marine organisms. Chichester Harbour has a resident fleet of over 12,000 vessels,
And unfortunately, the environment, it's in a very, very dire state. Chichester Harbour had a long tradition of an oyster fishery. The oysters have been, a delicacy for Queen Victoria about 100 years ago, more than 100 years ago. And unfortunately, nowadays, the oyster population is on its knees. The fisheries has been closed because of low number of oysters, and we are still trying to find a solution to repopulate and revive the oyster population in the harbour. Thank you very much for your attention, and I'll be happy to answer your questions. I have to acknowledge my sponsors, my funders, University of Brighton, and Interreg RedPol, the European Union program, Interreg channel, and those are my collaborators. Thank you very much.